that is the fourth unit is straight lines. Okay, just you have to see here. Now, this is the fourth unit straight line and the various forms of the equations of a straight line. And fifth unit is what is the skew lines and the shortest line segment between two skew lines. And the sixth unit is change of axis. Now, let us first of all we discussed the concept of what is a straight line and various forms of the equation of a straight line. Now, according to this one, just you have to see here what is the equations of a straight line. Now, here the how to converting the symmetric to non-symmetric and non-symmetric to symmetric. First of all, to any two general equations of the first degree in XYZ taken together represent a straight line. Now, just you have to see here. Here there are two straight lines here. One is just you have to see here. See this one. Let ax plus by plus cz plus d equal to 0. This is the first equation, and a1x plus b1y plus c1z plus d1 equal to 0. Say this is the second equation. Now there are two equations of first degree in xyz. Now according to this one, now according to this one, there are two planes, first equation and second equation, taken together represent a straight line, which is the line of intersection of two non-parallel planes. There are two non-parallel planes in between first equation and second equation here. Okay, and according to this, just you have to see here, any straight line can be put in this form by taking any two planes through it. Here, the general equation of a straight line, combining these two equations. Now, these equations represents a plane. It is the different of this part. Now, but both the plane equations joined. Now, just like that, one of the line of the formation here, let ax plus by plus cz plus d equal to 0, and a1x plus b1y plus c1z plus d1 equal to 0. This is there are two equations in the line unsymmetrical form or non-symmetrical form. Okay, now this is the non-symmetrical form of this part, because here there are it is an individual effort of this part. Here the plane equation is ax plus by plus cz plus d equal to 0, and a1x plus b1y plus c1z plus d1 equal to 0. There are two planes, but these two planes or these two equations must be of the form as one of the line formation. Now this is the unsymmetrical form. What is the symmetrical of this part? Just you have to see here. What is the symmetric? Now, symmetric form is okay. Now here the symmetrical form is the equations of the line AB passing through the point capital A of x1, y1, z1 and having a direction cosines Lm and R. Here x1, y1, z1 be any one of the point. That point means here according to the directions. Here AB, A is the one of the point and B is also another point. These 2 points connective passing through the point is x1, y1, z1, and according to this here the direction cosines Lmn. Now, here the direction cosine is known, and at the same time, the line of the point of the ds are here. Given the line of the point, A point is on the line. Okay, given that point capital A, x1, y1, z1, that point is on the line, and here that point is x1, y1, z1 here, and Lm be the direction cosines. Okay, now here the formation is just you have to see and here. Okay, what is that? Line representation. Here, say x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. Now, according to this is the symmetrical form. Now, here, according to the symmetrical form, what is the coordinates of the point? Coordinates of the point means that is the position, according to the position vector, AP bar means already point is x, y, z. Here, AB is one of the line according to this figure. Okay. Now here the xyz axis, this is the 3 dimension of this part. Just you have to draw the one of the line, AB is one of the line, and A is perpendicular point is Okay, please stay on the line.
Hello, can you hear me? Little bit problem is here. Now, please stay on the line. Hello. Okay, just try to see here. See this one. Now, already we have discussed the some other concepts. Just you have to see here. Please stay on the line. Please stay on the line. Some problem is here, so that's why now we are continuing through mobile app is there. Okay. Already we have discussed the what is the symmetric and the non straight line means now here the ax plus g. That's why okay. Now see and referred here. Equation of the line AB passing through the point capital A of x1 y1 z1 and having the direction is L M N or x minus L equal to y minus y1 by m equal to z minus z1 by n. Now that is LR plus x1 and MR plus y1 and NR plus z1. That is the coordinates of any point line. Okay. Now, this is what so that is the MR plus Y1 and NR plus Z1. This is the XYZ coordinates. Okay, XYZ coordinates on the given the given that point. Okay, that is LR plus X1, MR plus Y1 and NR plus Z1 is on the line. Okay, now this is the equation of the line through X1, Y1, Z1 and having a DRC ABCR. But changing the small conversation in the replacing between LMN by ABC. Okay, that is x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Okay, now see this example here. What is the example? See this one. Okay, now you just try to see and refer this one. Example is there. What is the example? Say this one. The equation of the line 2x plus 3 by minus 1 equal to 3 minus y by 4 equal to 3z minus 1 can be written in a symmetrical form. What is the symmetrical part? But just you have to observe given this line. This is the symmetric expression is x minus x1 by L equal to y minus y1 by m equal to z minus z1 by n. But here, given the equation of the line, the symmetric is 2x plus 3. So, 2 in the numerator 2x plus 3 divided by 2. In the numerator and the denominator divided by 2 is there. So, that's why here x plus 3 by 2 by minus 1 by 2 equal to 3 minus y can also be written as y minus 3 by minus 4. Minus is also common. Where minus is common in numerator and denominator. That's why it can be written as in the second part y minus 3 by minus 4 equal to third one 3z minus 1 by 2. Now this is also can be written in the form z minus z1 by n is there. But dividing by 3 in numerator and denominator the z minus 1 by 3 by 2 by 3 is there. Now given this equation given this example, just the given part, the given line part can be rewritten as in the symmetrical form. So that is x plus 3 by 2 by minus 1 by 2 equal to y minus 3 by minus 4 equal to z minus 1 by 3 by 2 by 3. Okay. This is the formation. Okay, directions of the line are what are the direction ratios in the denominator of the part is drs minus 1 by 2 minus what is that minus 4 and 2 by 3. Now that can also be written as this is also r 3 I that's 6 is also LCM. Now that can also be written as minus 2 twos are 4. So minus is also common. Now just you have to observe given the DRs. Minus 1 by 2, minus 4, 2 by 3. Now here the LCM is 6 is LCM. So that's why this can also be written as minus 3, minus 24 and 4. So minus is also common, common part is there, that it can also be written as DRs 324 minus 4. So this one very important example. Image problem, without image problem, we can't expect the final examination. Okay, find the image of the point 1, 3, 4 in the plane 2x minus y plus z plus 3 equal to 0. Now that is the problem. Okay. That is the problem. Point is that is the problem. So given the point here, the plane is 2x minus y plus z plus 3 equal to 0. A plane of the normals are 2 minus 1, 1 is there, and given the point is 1, 3, 4. Now here QB the just you have to image the QB any one of the image of the point 1, 3, 4 in the given the plane. Just you have to write the line equation through the points P and Q. Say Q point is x1, y1, z1 is there. Okay, or xyz, whatever it is. And according to that, here given the point is 1, 3, 4 is there. So x minus 1 by normals are 2 minus 1, 1 in the plane part. Okay, now here the normals part is 2 minus the symmetrical line is say small r, and write the coordinates of the point on the line, that is 2r plus 1 minus r plus 3 and z minus 4 by 1 equal to r. So that is z 4. So the coordinates of any point on the line q 2r plus 1, how to get the 2r plus 1? X minus 1 by 2 equal to r. So that's why that is 2r plus 1. And y minus 3 by minus 1 equal to r, that is minus r plus 3. Z minus 4 by 1 equal to r, 4 is there. So here the Q point is there. The midpoint of PQ is, what is the P point is known and Q point is known. So midpoint of the formula according to this one 1, 3, 4. P point is 1, 3, 4 and Q point is 2r plus 1 minus r plus 3 and r plus 4. So that's why the midpoint of PQ equal to 2r plus 1 by 2 and y x1 plus x2 by 2. Here x1, y1, z1 is 1, 3, 4 and x2, y2, z2 is Q point. So that's why 2r plus 1 equal to minus r plus 3 by 2 equal to r plus 4 by 2. So that's why we are getting the value is r plus 1 minus r plus 6 by 2 and r plus 8 by 2. Now, if this point is also substituting given this R value. So R value is also substituting in a Q. We are getting the image of the point. So 2 into R value is minus 2. So that's why 2 into minus 2 means minus 4 plus 1. So that is minus 3. Okay, minus of minus 2. So minus R plus 3 means minus of minus 2 plus 3. So 3 plus 2 is 5. And minus 2 plus 4, that is image of the point is 3, 5, 2. Now this problem is very important in the final examination. Don't forget, underline through 2 points. How to already we know in the that is the we have any 2 points. The join between any 2 points formula is line joining points formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Already this is also in the we have learned in the previous class, previous or lower session. Okay, lower level here any 2 points is given x1 y1 z1 x2 y2 z2 is given. line joining formula is x minus either first point or second point, whatever it is. You are taking any point is there. X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Now, this is the line joining here. The DRC is x2 minus x1, y2 minus y1, z2 minus z1. That DRs are denoted by, okay, LMN is there. That is automatically now that conversation is in the symmetrical form. X minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. Okay, here LMN is x2 minus x1, y2 minus y1, z2 minus z1. Either LMN or ABC, whatever it is. Okay. Now next one, see this one. Now here one of the example is here. There are 2 points is given minus 2, 1, 2 and 1, 2, 4. Okay. Now this is the, please, okay, this page number is, see the page number 103. Okay. Now here 103, just you have to see and refer this example. The equation of the line joining in between. Now these points are substituting in the above formula. That is x plus 2, x minus x1 means x minus of minus 2 means x plus 2 by x2 minus x1 means 1 minus of minus 2, 1 plus 2. Y minus y1 means y minus 1 by, that is 2 minus 1. Z minus 2 by 4 minus 2. So that's why we are getting the value is x plus 2 by 3 equal to y minus 1 by 1 equal to z minus 2 by 2. Okay, now the line joining between any 2 points, here we are getting the value is point is minus 2, 1, 2. Minus 2, 1, 2. Now given the answer is on the form, is in the form of a symmetrical part. So the line point is line transformation from unsymmetrical to symmetrical. How to converting to the symmetrical part from unsymmetrical part. Okay, we transform the equation. There are 2 equations is given here. A, B, C be the DRs of the line. Okay, now these equations can be in the non-parallel, means non-symmetric part is ax plus by plus cz plus d equal to 0 and a1x plus b1y plus c1z plus d1 equal to 0. It is also perpendicular to the normals to both of them. Okay. Now here the DRs means normals to be the planes. First normal is ABC. In the second plane is A1, B1, C1. There are 2 normals here. And according to that, we have to write the AA dash, BB dash, CC dash equal to 0. And again, A1A dash, B1B dash, C1C dash equal to 0. These 2 equations just by the right, this is the common part of A dash, B dash, C dash from the above normals. Okay. Now, according to the normals, just you have to write the 2 equations connecting with A dash, B dash, C dash. Now, here A dash, B dash, C dash are, that is the thesis of this part. By CMR expression, B, C, A, B and B1, C1, A1, B1. Okay. By CMR means cross multiplication rule. We are getting the value is A dash equal to, just you have to see this one, BC1 minus CB1 or BC1 minus B1C, and B dash value, B dash means you are taking the from the value of C. Okay, that is CA1 minus C1A. C dash means that is what is that? AB1 minus A1B. Okay, now that is the conversion of this part. Just you have to substituting in the symmetrical form x minus x1. What is the value of x1? X1 means just how to that is the x1 y1 z1. How to get the x1 y1 z1? Okay, now here z coordinate is 0. We are taking the equation is ax plus by plus d equal to 0. A1x plus b1y plus d1 equal to 0. So that's why any point is 0 means z1 coordinate is 0. We are getting the x1 y1 coordinate through the CMR expression. CMR means cross multiplication rule. Okay, write the y d dash. Okay, so that is the b d1 minus b1 d by ab1 minus a1 b and a1 d minus ad1 by ad1 minus a1 b. So z1 means 0 is there. Already we are getting the values of lmn is there. Okay, finally we are getting the symmetric expression for part or unsymmetrical form. Okay, just you have to see and refer the one of the problem is here. Example, find the symmetrical form of the equation of line. There are two, one line is also means the given planes are just you have to arrange the one of the formation of a line part. So that is a1x, b1y, c1z plus d1 equal to 0 and the second one is a2x, b2y, c2z plus d2 equal to 0. Here the coordinates are okay x plus y plus z plus 1 equal to 0 and second one is 4x plus y minus 2z plus 2 equal to 0 is there. So the given line is just you have to see and refer this one x plus y plus z plus 1 equal to 0 and the second one is 4x plus y minus 2z plus 2 equal to 0. Okay, here the normals are first plane of the normals, first equation of the normals 1 1 1, second equation of the normals 4 1 minus 2, that is the coefficients of x y z. Okay, now those normals we are taking in terms of ABC. So yeah, a into 1 plus b into 1 plus c into 1 equal to 0. That is a into 4 plus b into 1 plus c into minus 2 equal to 0. We are getting the two equations, that is a plus b plus c equal to 0 and second one is 4a plus b minus 2c equal to 0. Now just you have to write the by CMR expression. CMR means cross multiplication rule, that is a b c is there. So first one we are getting the value of a from the coefficients of b and c, the above two equations, that is b coefficient is 1 and second one the c coefficient is 2. So we are getting the cross multiplication rule 2 minus 2 minus 2 and minus 1. B value is we are just suppose B value is there and the cross multiplication rule from the first of all we are taking the reverse side. So 1 into 4, that is 4 minus of 1 into minus 2. So we are getting the minus of minus 2 is plus 2 is there. Okay, C value is the suppose we are getting the C value from the coefficients of A and B by CMR. So A coefficient is first equation A coefficient is 1, second coefficient B coefficient is 1. So 1 into 1 is there and first equation of the B coefficient is 1, second equation of the A coefficient is 4. So we are taking the AD minus BC. So from the in the above from the above two equations 1 minus 4 is there. So A value is minus 3, B value is 6, C value is minus 3. So minus 3 is common. So we are getting the values of ABC 1 minus 2. So okay, that is a cancellation. X plus y plus 1 equal to 0. And second one, 4x plus y plus 2 equal to 0. It is also same form. Suppose here getting z is equal to 0 from the coefficients of y and that is the CMR expression. So solving these two equations, we are getting the x1, y1 is there and z coordinate is 0 is there. So write the symmetrical form here x minus of minus 1 by 3, x plus 1 by 3 by 1, y plus 2, 3, 2 by minus 2, z minus 0 by 1 is there. Okay, so x plus 1 by 3 by 1 and y plus 2 by 3 by minus 2 and equal to z by 1 is there. That is the conversion of symmetrical form from non-symmetric means unsymmetrical expression. This problem is also very important. Listen, students, listen carefully here. This is one of the important concepts. Okay, listen carefully. This problem is very important. Please stay on the line. Please note down. Okay. Now this one is also very important, students. What is that? Point is given and a line is given. Line and a plane is given, and to find the image of the line from the line. Already we have find the from the point and the plane, find the image. Okay. Now this problem, especially this problem, okay, change the line. Some other expression is also there. See this one. Line intersecting given two given lines. This is the one of the part. It is given. There is here. For show that the lines are open. Point one. This one is also very important in the examination. This is the volume of the tetrahedron. This is not necessary. Okay. This problem is also just you have to practice it. See this one. Now this is the transformation of the part. Already problem is also practiced here. See this one. So that the equation of the line through the point 1, 2, 3, and it is also parallel to the line, that is x minus y plus 2z equal to 5 and 3x plus y plus z equal to 6. So point is given, that point is also parallel to the line. First of all, given line is, okay. So the find the equation, how to get the equation? First of all, write the equation, and here a, b, c be the drs of the required line. So this is also, it is parallel to the first equation, and the drs of the given line are a, b, c is there. So from the coefficients of given equations, 1 minus 1 2, and the second one is 3 1 1. These two equations right in the normal, from the normals ABC are written as a minus b plus 2c equal to 0, and second one is 3a plus b plus c equal to 0. And according to these equations, here A, B, C be the DRs. Okay, to write to find the values of A, B, C by CMR. So we are getting the values: A value minus 3, B value is 5, and C value is 4 is there. Okay, and the first point is given, the point is 1 2 3. To write the symmetrical form, x minus 1 by minus 3, y minus 2 by 5, and z minus 3 by 4. That is the symmetrical form. Point is given, that point is parallel to the plane equation, parallel to the line equation. Okay, that's enough. Now these problems are also practiced here. And next one, see this one, angle between a line and a plane. This is also one of the important. So already angle, we know that angle between any two planes or angle between any two lines is there. We know that the formula cos theta equal to a1 a2 plus b1 b2 plus c1 c2 by, so that is the root of sigma a1 square into root of sigma a2 square. But here what is the line is given? Line normals means x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. Say that is the first equation. And the plane is x plus by plus CJ plus DG and D another side B. So according theta equal to, so theta be the required angle and the normal in the plane. So the angle is pi by 2 minus theta. So the line and a plane of the angle in the trigonometric ratio is sin theta equal to, how to get the sin theta? Cos of pi by 2 minus theta. So cos 90 minus theta is sin theta. So that's why sin theta equal to, according to the normals of the line and a plane. So that is AL plus BM plus CN by root of sigma A square into root of sigma L square. Sigma A square means A square plus B square plus C square. Sigma L square means L square plus M square plus N square. This is also, suppose line is parallel to the plane. Line is parallel to the plane means condition is, that is the reverse of the part. Okay. So parallel means the theta value is 0 degrees. So sin 0 is 0. We are getting AL plus BM plus CN equal to 0. If a line is parallel to the plane, parallel means theta value is 0 degrees, either 0 or 180 degrees there. Suppose you are taking the replacing by theta to 0 degrees, sin 0 is 0. After the cross multiplication, we are getting the AL plus BM plus CN equal to 0. That is the required condition. Suppose line is perpendicular to the plane. So theta equal to 90 degrees. Sin 90 is 1. So the normals are also proportional. So that is A by L equal to B by M equal to C by N. So A is to L equal to B is to M equal to C is to N. That also can also be written as. Okay. Now here the angle between the line. Problem is just you have to see and refer. The angle between the line and the plane. So x plus 1 by 2 equal to y by 3 equal to z minus 3 by 6. That is the given the line. And 3x plus y plus z equal to 7. That is the plane. Okay. So line normals are 2, 3, 6 and plane normals are 3, 1, 1. Okay. Now these substituting in the formula, so this sin theta equal to, okay, sin theta equal to AL plus BM plus CN. Those values are substituting, given the above formula by root of A square B square C square into root of L square plus M square plus N square. So we are getting the value is 15. So theta value is the sine inverse of 15 by 7 root 11 is there. So these problems are also practiced here. Okay. So plane normals are 2, 3, 4. Just you have to check the progress. Line and a plane is given and according to the normals to find the angle. So that the trigonometric ratio is sin theta equal to AL plus BM plus CN by root of A square plus B square plus C square and root of L square plus M square plus N square. So point of intersection of the line with the plane. So let the given line be here. Point of intersection of the line with the given the plane. So line is also there. X minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. Say that is the given the line first equation. Plane is AX plus BY plus CZ plus D equal to 0. So that's why that is the required plane. So coordinates at the point is from the line LR plus x1, MR plus y1 and NR plus z1 given the line. That is the first equation. Okay. So that equation of the normals is substituting that point. Coordinates of the point is substituting given the plane. So A of x means LR plus x1 and y means MR plus y1 and z means NR plus z1. Those values substituting given in the plane, we are getting the value is, so R value is there. Okay. So that's why that is the required point of intersection. So problem is also just you have to see and refer. Find the coordinates of the point of intersection. Point of intersection of the line. So x plus 1 by 1 equal to y plus 3 by 3 equal to z minus 2 by minus 2. So that is x minus of minus 1 by 1 equal to y minus of minus 3 by 3 equal to z minus 2 by minus 2. So with the plane 3x plus 4y plus 5z equal to 5. So first of all, write the given the line. So say that is a small r. be any point smaller, that line is an equivalent to small r, say. So if a required point is r minus 1, 3r minus 3 minus 2r plus 2. Suppose first of all x coordinate is, suppose first of all, so we must know the x coordinate means x plus 1 by 1 equal to r. So x plus 1 equal to r. So x equal to r minus 1. And again y coordinate is y plus 3 by 3 equal to r. That is 3r minus 3. Z coordinate is the same. It is on the same manner, minus 2r plus 2. So that value is substituting when the point of intersection means x y coordinate z coordinate, that coordinate is substituting given in the plane, we are getting the r value. So that r value is substituting in the coordinates of the point, we are getting the point of intersection. So that is 1, 3, 2 is there. So it is also same manner. This problem is also practiced. Okay, conditions for a line and to a line in a plane, very important. The line in a plane condition is, that is, first of all, write the line equation, x minus x1 by L, y minus y1 by M, z minus z1 by N is there. So line in a condition is A plus N. Okay, plane condition is plane is ax plus by plus cz plus d equal to 0, and here the condition is al plus bm plus cn equal to 0. And again, to write as the ax1 plus by1 plus cz1 plus d equal to 0 is there. There are equation line and a plane. Okay, that is the simple. Just you have to see for the problem corollary 1. So line is parallel to the plane. Line is parallel to the plane condition. Line in a plane means line is parallel to the plane. So that is AL plus BM plus CN equal to 0. Here theta equal to 0 degrees from angle between a line and a plane. That is also in the same manner. Okay. Next one. Coplanar lines. What is the meaning of coplanar lines? Conditions for the coplanarity of lines. What is the coplanar? The given points is on the same plane. That is called a coplanar. But here there are two symmetric lines is there, and according to the symmetric, just you have an equivalent, that is x coordinate is x minus x1, y minus y1, z minus z1. That value is substituting given in the plane. So a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. And according to the DCs L1, M1, N1 from the first line, AL1 plus BM1 plus CN1 equal to 0. So from the equations, we are getting the, from the determinant of this part, mod x2 minus x1. That is, according to the both the lines are symmetric. Hence the condition is mod x2 minus x1, y2 minus y1, z2 minus z1. And first line of the normals L1, M1, N1. Second line normals are L2, M2, N2. So according to their then the determinant of the part equate is an equating to 0. So we are getting the lines are coplanar. So how to write the equations? How to get the equations? Means mod x minus x1. Okay. From the mod x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0 over R. Okay. Either x1 minus x2 or y1 minus y2. No, there is no problem. Okay. There is no problem. Now, how to get the equations from the first line? Mod x, the same determinant of this part, we are taking mod x minus x1, y minus y1, z minus z1, and L1, M1, N1, L2, M2, N2 equal to 0. And from the second line equation, to write the plane equation is how to get the plane equation. Mod x minus x2, y minus y2, and z minus z2 by L1, M1, N1, and L2, M2, N2 equal to 0. From this is the line, that is the plane. It represents the plane which passes through the line first equation and is parallel to the second line. Okay. Just you have to see this problem. Show that the lines, there are two lines, both lines are coplanar, and find the equations connecting them. So this problem is very important. First of all, to write the given the equations, and according to these lines, to substituting from the coplanarity condition, mod x2 minus x1 y1 z1 is -3 -5 -3 -5 7, and the second line is -1 -1 -1. So here condition of coplanarity is mod x minus x1 y minus y1 z minus z1. So that value substituting, we are getting and their determinant is 0. So to write the equation means mod x from the first line equation, mod x minus x1 y minus y1 z minus z1 L1 m1 n1 L2 m2 n2 equal to 0. To find the determinant, we are getting the equation. Okay, now that is the simple part. Students, listen carefully. This problem is very important from the coplanarity condition. Okay, line intersecting two given lines, very important concept. Okay, line intersecting given lines. How to the given lines, how to intersect? There are two given lines are intersecting means find the equation of the, just you have to see and refer the problem. Okay, now find the equations of the line intersects the line. Line intersects the lines. So first one is the non-symmetric, second one is the non-symmetric. So first line is there is no z 2x plus y minus 1 equal to 0 equal to x minus 2y plus 3z. That is the first non-symmetric or unsymmetrical part. And second one is also non-symmetrical part. That is also involving, there are two planes. It is an individual part, but it is also one of the line formation. That is the second non-symmetrical is 3x minus y plus z plus 2 equal to 0 equal to 4x plus 5y minus 2z minus 3. So both lines, and it is also parallel to the line is x by 1 equal to y by 2 equal to z by 3. Okay. First of all, to write the general equation from the first non-symmetrical part. So 2x plus y minus 1. Any two planes are when the given the first non-symmetrical, there are two equations. So first equation plus lambda into second equation equal to 0. And now x y enter that equation in terms of plane effort. Here x of 3 plus 4 lambda 1. And second one is 3x minus y plus z plus 2 equal to 0 plus lambda 1 of 4x plus 5y minus 2z minus 3 equal to 0. So finally, now both equations involving in terms of x, y, z is there. So when it is parallel, lambda 1 and lambda 2 are be to choosing. There are two planes representing in separately parallel to the given line. So already parallel normals are x, y, z normals are 1, 2, 3 is there. So those values are substituting in the above two expressions. We are getting the lambda and lambda 1 values. So already substituting means here 1 of 2 plus lambda 1 plus 2 of 1 minus 2 lambda 1 plus 3 of 3 lambda 1 minus 1 equal to 0. We are getting the lambda 1 value, and it is also in the same manner, same normals element xyz coordinates substituting in the second part. Okay, so those lambda 1 and lambda 2 is substituting. Finally, we are getting the line equation is there. That is the very simple part. Okay, students. Now this is one of the important problem from the that is the non-symmetrical equations converting into the one of the representation of a line is there. Okay. Now for 4.8.1, this problem is very 4.8.1 important. Find the distance of the point -1, -5, -10 from the point of intersection of the line. Point of intersection of the line means line is given and plane is given, and here point is also given. Distance means first of all, to write the symmetric part, say that is small r, and write the coordinates of any point on the line. That is 2r plus 2, 4r minus 1, 12r plus 2 is there. so that any point on the line, so that point is substituting given in the plane, we are getting the value of R. Okay, so R value is substituting in the above part, we are getting the required point of intersection is 2 minus 1, 2. So the given line meets the given point at the point is 2 minus 1, 2 is there. Okay, what is the distance between the given the points? Already one point is given, and remaining point is also just we have found the value of a second point. Okay, in between distance between 2 points is square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. Already one point is given, minus 1, minus 5, 10, and second point is also just to have found that value. Okay, square root of 2 minus, what is that? 2 minus of minus 1 means 2 plus 1 whole square, and again minus 1 minus of minus 5 plus 5 whole square, and last one 2 minus of minus 10, so that is 2 plus 10 whole square. We are getting the value is root 169 means 13. Okay, so that's enough. 4.8.1, that problem is very simple, as in the short problem, short question is there. Okay, now 4.8.2, this problem is also very important. Just you have to see and refer this one. Okay, now 4.8.2, 4.8.2 problem very important. Okay, and at the same time 4.8.4, this problem is also important. And the last one, as in the essay question, 4.8.5, line is perpendicular to the plane. And one of the important, there are 4 points is given. There are 4 points is given. Now these points are collinear. Okay. First of all, you are taking the first 2 points. So the problem is 4.8.6. To write the line joining in between 2 points. So according to the line joining, for first 2 points is AB, and the remaining 2 points is CD. So to write the CD point, from the CD point, C point is substituting in the above expression, we are getting that value is 0. And same, any point is substituting in the first 2 points of the line joining expression. So then automatically, and the remaining D point is also substituting, we are getting the same. Okay, so C and D points are substituting from the first 2 points of the line joining expression, then automatically given the points are collinear. That is the simple expression. 4.8.7, this is one of the most important problem in the final examination. Please note down 4.8.7. This problem is very important. Now tomorrow we will discuss this problem, some little bit disturbance from the network side. So that's why kindly excuse me. Now, if you have any doubt according to the symmetric and non-symmetric part, now 4.8.7 is also very important. Image problem must and should it is given in the final examination. Don't forget this one. Image of from the point and the plane, from the point and the line, from the line and the plane is given. Okay. Now, how to find the image? So on behalf of this way, where this problem is also very important, 4.8.7. Okay, don't forget. Okay, thank you. Tomorrow we will continue to make. Tomorrow we will discuss some other important problems, because according to my schedule, tomorrow is the last session through online. Okay, tomorrow we will discuss some other important problems and the remaining topics. Okay, thank you one and all. Wish you all the best. If you have any doubt through WhatsApp, okay, already I have given my personal number, and for the subject point of view, just you have discussed we will discuss through WhatsApp. If you have any doubt, please call me. Okay, through WhatsApp is there. Okay, thank you one and all. Wish you all the best.